When most people talk about Linux, they usually imagine one giant operating system with dozens of different skins layered on top of it. They think Ubuntu, Fedora, Arch, Debian, OpenSUSE, and every other Linux distribution are essentially the same thing underneath, just with different desktop environments, package managers, and branding. It is one of the most common assumptions repeated in tech discussions, YouTube videos, and online forums. This idea sounds reasonable at first because every major Linux distribution uses the Linux kernel. That shared foundation makes it easy to believe they are all just variations of one operating system. If they all boot using Linux, run similar command line tools, and execute many of the same applications, then surely they must just be different flavors of the same thing. It feels like a simple explanation for a complicated ecosystem. But here is the uncomfortable truth that many Linux users never fully acknowledge. This belief is one of the biggest oversimplifications in modern computing. It is not entirely false, but it hides the deeper reality of how operating systems are built and what actually defines them. The Linux world is far more diverse than most people realize. The kernel itself is only one piece of an operating system. It is an incredibly important piece, but it is not the whole system. The kernel handles communication between hardware and software, memory management, process scheduling, drivers, and low-level resource allocation. It is the engine of the machine, but an engine alone does not make a complete car. If someone handed you an engine and said they gave you an entire vehicle, you would immediately know something was missing. You would still need the frame, transmission, steering system, controls, electronics, and bodywork. In the same way, the Linux kernel needs a complete surrounding ecosystem to become a usable operating system. Without that surrounding structure, it is just a powerful but incomplete component. This is where Linux distributions come in. Every distribution takes the Linux kernel and builds an entire operating system around it. That includes package management systems, software repositories, release schedules, system libraries, desktop integration, security frameworks, default configurations, and countless engineering decisions. These choices shape the identity of the system in profound ways. The moment you understand this, the illusion begins to collapse. Linux distributions are not simply the same operating system wearing different wallpapers. They are complete systems built with different goals, philosophies, and technical foundations. Sharing the same kernel does not make them identical any more than sharing the same CPU architecture makes Windows and Mac OS the same operating system. Take Ubuntu and Arch Linux as an example. Both use the Linux kernel, but they feel entirely different from the moment you install them. Ubuntu is designed to be accessible, polished, and predictable. It aims to make Linux approachable for beginners while maintaining enough power for advanced users. It comes with carefully chosen defaults and emphasizes ease of use. Arch Linux takes the opposite approach. It is intentionally minimalist and gives users almost nothing by default. Installing Arch requires manual setup, detailed configuration, and a willingness to understand the system deeply. It assumes the user wants full control over every component. This creates an experience that feels radically different from Ubuntu. Calling these two systems the same operating system simply because they use the same kernel is like saying a Formula One race car and a family minivan are the same, because both use internal combustion engines. Yes, they share a fundamental technology, but their design, purpose, and user experience are completely different. The differences become even more dramatic when you examine package management. Ubuntu uses apt and deb packages. Fedora uses DNF and RPM packages. Arch uses Pacman. Gentoo uses Portage. NixOS uses Nix. These are not cosmetic differences. They fundamentally change how software is installed, updated, managed, and maintained. Package managers define much of how users interact with an operating system. They determine dependency resolution behavior, repository structure, software availability, and upgrade strategies. Learning one package management ecosystem does not automatically make someone fluent in another. Anyone who has switched between them knows there is a real adjustment period. Then there is release philosophy, which dramatically shapes how a system behaves over time. Ubuntu LTS focuses on stability and long-term support. Fedora prioritizes innovation and rapid adoption of new technologies. Arch uses a rolling release model that continuously delivers the latest software. Debian Stable moves deliberately and values reliability above all else. These release strategies affect everything from hardware support to software freshness. A gamer using Arch might have access to the latest graphics stack immediately, while a Debian Stable user might be running older but heavily tested versions. Both systems are Linux-based, but their daily realities are completely different. This distinction becomes even more obvious when looking at system configuration philosophy. Ubuntu generally favors automation and convenience. Arch expects manual intervention and configuration. Gentoo goes even further by requiring users to compile much of their software from source, allowing deep customization through compile time options. That level of control creates an entirely different relationship between user and system. Gentoo users often understand their systems at a much deeper technical level because the distribution requires it. Ubuntu users, on the other hand, can often accomplish their goals without needing that complexity. These are fundamentally different operational models. Now consider NixOS, which pushes the idea of operating system design in a completely different direction. Instead of relying on traditional scattered configuration files, NixOS uses a declarative configuration model. Users describe the desired state of their system in a central configuration file, and the system builds itself accordingly. This approach changes everything. It enables reproducibility, rollback capability, and deterministic system builds. Updating a NixOS machine feels nothing like updating Ubuntu or Fedora. It is not simply Linux with a different package manager. It is a completely different philosophy of how operating systems should work. Alpine Linux provides another striking example. It uses Musl libc instead of glibc, the standard library used by most mainstream Linux distributions. This seemingly small decision has major implications for software compatibility and system behavior. Applications compiled for glibc often need modification to run on Alpine. That one technical decision makes Alpine distinct enough that developers often need to specifically account for it when deploying software. This is one of the clearest demonstrations that Linux distributions are not interchangeable. The shared kernel does not erase these deep structural differences. Desktop environments add another layer of complexity. Many people think desktop environments define the distribution experience, but that is only part of the story. KDE Plasma on Fedora does not necessarily behave the same as KDE Plasma on OpenSUSE. GNOME on Ubuntu is not identical to GNOME on Debian. Distributions package desktop environments differently. They apply patches, choose different defaults, integrate distinct tools, and update at different rates. This means even when two systems run the same desktop environment, the experience can feel noticeably different. The underlying distribution still matters enormously. The Linux ecosystem also differs significantly in governance. This is one of the most overlooked factors in defining an operating system. Ubuntu is heavily shaped by canonical and its strategic decisions. Fedora is strongly influenced by Red Hat. Debian is governed by a community voting process. These governance structures affect technical priorities, release schedules, feature adoption, and overall system direction. A corporate-backed distribution often has different incentives than a purely community-driven one. That influence becomes visible throughout the operating system. Security models further emphasize these distinctions. Fedora strongly integrates SE-Linux. Ubuntu uses AppArmor by default. Some distributions prioritize hardening aggressively, while others focus more on flexibility. These choices shape both security posture and user experience. A user troubleshooting permission issues on Fedora is dealing with a different security architecture than one on Ubuntu. This changes how the system behaves, how problems are diagnosed, and how administrators interact with it. Again, same kernel, different operating system reality. Software support also reveals the myth. Developers often say their application supports Linux, but this usually means they support certain distributions. A binary built for Ubuntu may not run cleanly on Fedora. An RPM package cannot be installed directly on Debian. Dependencies, library versions, and runtime assumptions vary. This is why technologies like Flatpak, Snap, and AppImage exist. They attempt to bridge the fragmentation across Linux distributions. If every distro were truly the same operating system, these compatibility layers would not be nearly as necessary. Even kernel versions themselves vary across distributions. Some ship the newest upstream releases quickly. Others backport fixes into older versions. Some apply custom patches optimized for security or hardware enablement. This means two Linux systems may behave differently even at the kernel level. These differences can affect hardware compatibility, driver performance, battery life, scheduling behavior, and overall responsiveness. For users, this translates into practical differences that shape everyday computing experiences. The myth persists partly because simplification is convenient. It is easier to tell beginners that all Linux distributions are basically the same. That explanation lowers the barrier to entry and reduces confusion. It gives newcomers confidence to explore without feeling overwhelmed by endless choices. There is value in that simplification, but only up to a point. Once someone starts using Linux seriously, the differences become impossible to ignore. Treating all distributions as interchangeable creates unrealistic expectations and often leads to confusion when systems behave differently. Another reason this myth survives is community identity. Many Linux enthusiasts prefer emphasizing unity rather than fragmentation. They see all distributions as part of a larger movement built around open-source software and user freedom. There is truth in that perspective. Linux distributions do share important foundations. They often use similar command line tools, common standards, and overlapping software ecosystems. This creates a sense of continuity that makes the Linux world feel connected. But shared roots do not erase individual identity. Think of languages derived from Latin. Spanish, French, Italian, and Portuguese all share deep structural similarities. They have common ancestry and recognizable overlaps. Yet no one would seriously claim they are the same language. Their differences matter. Linux distributions are similar. They belong to the same family, but each has evolved in its own direction. Their distinct philosophies, architectures, and workflows make them separate operating systems built upon shared heritage. This diversity is actually one of Linux's greatest strengths. It allows experimentation, innovation, specialization, and choice. It enables systems optimized for servers, desktops, gaming, embedded devices, penetration testing, scientific computing, and immutable deployments. Without this diversity, Linux would not be nearly as adaptable or powerful. The freedom to create distinct operating systems around a shared kernel is what gives the ecosystem its extraordinary range. Understanding this changes how users should approach distro selection. Choosing a Linux distribution is not just choosing a desktop theme or package manager preference. It is choosing an operating system philosophy that shapes how you interact with your machine. Some users value stability and predictability. Others want bleeding-edge software. Some prioritize reproducibility. Others seek maximum customization. Different distributions serve these different priorities because they are genuinely distinct systems. The next time someone says all Linux distros are just the same operating system with different skins, it is worth challenging that assumption. Ask them whether NixOS and Ubuntu are really the same. Ask whether Gentoo and Fedora Silverblue offer identical experiences. The answer becomes obvious quickly. The Linux kernel may unite them, but everything built around that kernel defines what they truly are. And what they truly are is a vast family of unique operating systems. The kernel is the foundation, not the identity. The identity comes from the architecture, tooling, philosophy, governance, and engineering choices layered on top of it. That is what shapes user experience and defines an operating system. So yes, Linux distributions share the same kernel. But no, they are not all the same operating system. That is the kernel lie, and understanding why it is false reveals just how fascinating the Linux world really is.